Okay, welcome back. Yes. So in last session we have seen that how to write the architecture body, that too in the data flow style for a given digital circuit as following the syntax. Okay. So what is the syntax of architecture? It starts with the word architecture, then architecture name. Name is user defined name of entity name is. This is the first line usually. Then any declarations if you have, you can declare. After that, after declarations, the word begin. After that, statements. In the data flow style, the statements are, okay, actually as per the syntax, concurrent statements. The statements are called in the architecture body or concurrent statements. So what type of concurrent statement in the data flow style means? That is signal assignment statement. Okay, signal assignment statement. Okay. Then end architecture name. Now today I would like to discuss the another architecture model, that is maybe so okay. So I think, have you written the data flow style architecture for the full ladder? Okay, so have you written or not? If you write, okay. Otherwise you can check here, whatever you can check with this. So in case of full ladder, we have 3 inputs and 2 outputs. The 3 inputs are A, B, C in as per my diagram, and 2 outputs are sum and carry. Since the type of architecture body is data flow style, that's why I am going to take the Boolean expressions for sum and carry. So what is the Boolean expression for sum? Sum equal to A XOR B, A XOR B XOR C. Whereas carry is AB plus BC in plus C in A or A C in. Okay, like that you can take the Boolean expressions for sum and carry of full adder. Now here check the program. So first of all, entity declaration. The entity declaration includes, or it starts with the word entity. Its name full adder is. Then port includes all inputs and output signals. How many input signals here? A, B, C, N. So all I am declaring in the single line. So A, comma B, comma C in colon in standard logic. Similarly, both outputs declared in the same line, that is sum, comma carry colon out standard logic. Okay, so all input signals and output signals are declared here, and end entity name, that is end full adder. Okay, so that is the entity declaration. In the entity declaration, you can represent all input ports and output ports. Okay, that too with their data type. Then the second part of the program is, that is architecture body. As per the syntax, it starts with the word architecture, an architecture name df. My name is df, means data flow of entity name, that is full adder is begin. So after begin, the statements are signal assignment statements. Because it is a data flow style, so I am using only signal assignment statements here. One statement for the sum output, another statement for the carry output. Okay, so for sum output, how to write the signal assignment statement is, as I said, it is like a Boolean equation. So sum less than equal is the signal assignment symbol. Okay, that is, if any object declared as a signal, less than equal symbol you have to use while assigning a value. Okay, so since sum and carry are represented in the entity, they are treated as a signals. Okay, whatever the objects declared in the entity, all those objects are declared as a signals. Okay, so defaultly sum and carry are the signals, so assignment symbol is less than equal. So A XOR B XOR third input is C in. Similarly for carry less than equal. Okay, as per equation, A logical and B put better this operation in the bracket, then followed by or operator instead of plus. Here plus represents logical or operation, right? So or of B and C in or A and C in, okay, semicolon. So each statement must be ended with the semicolon. Then end architecture name, end architecture name. So what is the architecture name here? DF. Okay, DF I have taken, so that's why DF. Okay, so this is the entity declaration and data flow architecture body for the full adder. Okay, so actually this is assignment I have given in the previous session, so you can copy, or if you write already you can check it whether have written correct way or not. Okay, now I will move to the another style of architecture body, that is hierarchical structural representation. Actually structural model, usually called structural model. The structural model follows hierarchical fashion. Okay, hierarchical fashion. Okay, so in the to write the program in the structural model, what information you need to know from the digital circuit is, that is logic diagram. Okay, logic diagram, you must know the logic diagram of the digital circuit, otherwise it is difficult to write the structural program. Okay, so when you know the logical program, then you can easily write the architecture body in the structural style. Okay, and here one declaration is compulsory in the structural model. That declaration is component declaration. Component declaration. Okay, in the structural style of modeling. Okay, in the declarative part of architecture, one declaration, that is minimum one declaration is compulsory. That too, that is component declaration. Okay, so let us see the syntax for the component declaration first of all. After that we will see how to write the program for a simple digital circuit. So now coming to syntax of component declaration, the syntax is, it is similar to, the syntax is similar to entity declaration, but here it start with the word component. Start with the word component, then name of the component is, next line start with the port of different signal names, signal name colon, each one declared as signal name colon mode data type means data type. Okay, semicolon. Like that many signals you can declare in the port. After that end component name, right? So see, it is just like entity declaration. If you see, the syntax of entity declaration also same, but only the difference is there instead of component, the entity word entity we are writing. Similarly, at the end component, here a component is compulsory, but there end entity name directly, entity name. So like that the syntax of component you can observe. Now coming to see one example component declaration, that is for NAND gate, 2 input NAND gate. How can you write the component declaration for the 2 input NAND gate is, start with the word component followed by name of the component, whatever the name you can write, but usually the name should be proper. Since it is a 2 input NAND gate, that's why I have given the name as NAND2. It means 2 input NAND gate it is. Component here is a 2 input NAND gate. Okay, is. Then port of 2 input NAND gate means how many inputs and how many outputs? 2 inputs and 1 output. The inputs are named as A, B, but output is Z. So AB in bit semicolon and output is declared as Z colon out bit. What is bit is? Bit is a data type, predefined data type. It is already there in the language. Okay, standard logic also a data type. Previously we observed that the predefined data type is standard logic. Now I am using the data type is bit. Okay, many data types are there. So user can select one of the data type based on the data which the digital circuit has to work, and which the digital circuit has to work. Okay. So then end component. So if you observe here, the component declaration is similar to the entity declaration. The component declaration is similar to entity declaration. Okay. So is it clear? Now I am just moving to the structural style of architecture. That is okay. And another thing you have to know, that is, yes, this information also you need to write, or you need to know. So in the structural style of architecture, what type of concurrent statement we are using in the statement part is, that is component instantiation. The statement is called component instantiation. Okay. And if you observe, its a syntax is, it starts with the label name. It starts with label name, colon, component name. Component name is whatever the component declaration we declared in the declarative part. Then port map of association list. Port map of association list. Okay. So this is the syntax for the component instantiation. I think here I am not proposing. Okay. Example also is there. For the same component NAND gate, how the instantiation statements will be developed is, start with the label name. Label name also user defined name, colon. Component name is whatever the name you have given in the component declaration case, same component name you have to use. Then port map of the different inputs and outputs as per the logic diagram, which inputs are connected to that component and output is to which. Okay, what are the object names or signal names or wire names? As per the diagram, you can write the association list. Okay, so if you write one logic diagram in the architectural model, then you can easily understand how the association list can be represented. Okay. Let us see. Okay, so here is the structural program for the same half adder. Let us take the half adder diagram, and for this half adder case, entity already in previous session also we observed the entity declaration. Now let us see how to write the structural architecture model. Okay. So since this is the logic diagram, it consists two components. One is the XOR component and another one is AND gate component. XOR gate component and another one is AND gate component. Both are having two inputs and one output. Initially, I have given the names to each and every component, like XOR gate with X1, AND gate with A1. Okay. So these names are used as a label name. Label name, while writing the instantiation statement, start with the label name. Okay, so these names you can use as a label name. Okay, and now see the writing of the architectural model, that is architecture in the structural model. Okay, start with the word architecture followed by architecture name. Here I am giving the name as str of entity name of adder is. Then I said that one component declaration is compulsory, but here we have two different components. So two component declarations you have to write. One component declaration for XOR gate and another component declaration for AND gate. Okay, so two component declarations I have written. Then begin, after begin, instantiation statements you have to use. But here how many instantiation statements? The number of instantiation statements equal to the number of components. Here two components we have, one is XOR component and another one is AND component. So the two instantiation statements. So for first one, the statement is start with the label name X1 colon. For this component, what is the component name? XOR2, then port map of. So what are the inputs to this XOR component as per the diagram? A, B. So A comma B comma, what is the output as per the diagram? Sum. So the order you have to follow. First The order how the component declaration port is represented, in the same order you have to write in the association list case. Okay. Similarly, the instantiation statement for the AND gate. Okay. Then finally, end architecture name. Okay. So now I am going to stop this session. In the next class, once again we will discuss this structural model. Right.